In the Go programming language, we can defer the execution of a function. To make a deferred function call, we prefix a regular call of a function with the keyword defer. That technique postpones the execution of a function till the end of a current function. Let me demonstrate that on the example. First, we call a printline function. Then we defer the second call. After that, we call a printline function again. Let's run the program and check the result. As we can see, the order of our output messages has changed. First, we see the message 1, followed by 3 and only then by 2. That's because the deferred function call was postponed till the end of the main function. When we have several different function calls, they are going to be executed in the reverse order, as a stack, the last in, first out. You may wonder, what values does a deferred call get? What if I pass a certain value to a function we defer and change it down the road? In this case, the function gets the current value at the moment it was deferred. Let me demonstrate that. First, we print an initial value of n. Then we increase the value by 1 and print it out. Then we print out the value again, but this time we defer the execution. Then we increase the value one more time and print it out. As a result, the value from the deferred call remained the same as on the second step, which is 1. It is worth to mention that deferred calls are being executed after the return value of the current function. Let me create another example. In this example, inside the function inc, we print the message when the function gets called. Then we defer another message, increase a number and return the value. To return a value, we call another function, which prints yet another message inside it without changing the value or variable n. In the main function, we call inc function and print its result. We can see what deferred message was printed after the returning message. At this point, you may wonder how all that can be helpful. Using deferred function calls helps when we need to clean up some resources or close open connections or files. Let's take another example, where we are going to open a file, read its context, and close the file. Between the opening and closing the file, there could be many and many lines of code. Here's a couple of scenarios of how things can go wrong. First, when we open a file, we need to remember to close it. We can simply forget, so that can cause a human error. Second, when a function has early returns, then every time we return from the function, we need to close the file as well. That can result in both human errors and code duplication. Using defer, we can close the file right after we open it. In this case, that's enough to call it once. because the program is going to run it when the function finishes its work. It is also more readable from the developer perspective. They can see the file is open and there is a deferred file clause.